Okay, but the first one, we do have to make our own equation. So this one says determine the weight of a small box if a scale shown below in here is balanced, okay? So I see that I have a balance here, right? So I have this left side. I just draw a line here, I guess. So I have this left side is equal to the right side, right? Because they're balanced. So I know that this pendulum, or this, I think it's called a fulcrum, I believe, is our balancing point. So this is like our equals sign. So I'm just saying that the weight of the left side is equal to the weight on the right side. Okay. So I don't know what the weight of the small box is, right? But I do know how many small boxes I have. So how many small boxes do I have on this left side?
6.
6, right? So I'm going to say 6 boxes. So 6b is equal to, and I know that I have 4 boxes on the right. And how many pounds do I have on the right?
15.
Mm-hmm. Yeah, I have 15. So I'm going to add 15 to this. So I'm saying that the weight of 6 boxes is equal to the weight of 4 boxes plus 15 pounds. So does anybody have a guess on how I can start solving for B? Well, is there anything I can do to kind of remove any small boxes on both sides? And make sure it's still balanced? Well, what if I take out 4 boxes on the right and I take out 4 boxes on the left, right? So I'm just removing 4 boxes from each side, and it's still going to be balanced, right? Because I'm taking out 4 on the left and 4 on the right. So I can write this algebraically as I'm doing it down here. I can just write this by just subtracting 4 boxes on each side, because we're just taking out 4 boxes on each side, right? So I end up with 2b, or 2 boxes on the left, and that's equal to the 15 pounds that's left on the right. So now how can I solve for this? How can I solve for 2b equals 15?
Divide by 2 on each side.
Yeah, just divide by 2 on each side, right? So b is equal to 7.5. Right? So we just divide both sides by 2. Right? So what is this saying? So what does b equals 7.5 mean?
Then a small box would equal 7.5 pounds.
Yep. So that's just answering our question from above, right? So just the weight of each small box is 7.5 pounds. Yep, exactly. Okay. So all the equations that we've done so far, we call these linear equations. And basically what that means is that our highest degree of a variable is 1. So like 6b, 4b. So anything with just like an x or just some variable that is to the first power, and that's our largest one, is a linear equation. So another example they give is what? 15x minus 11 equals 2. That's a linear equation. An example of one that's not a linear equation is 7x squared equals 9. And that's because it has this squared where the x is. Okay, so let's take these ideas of solving in linear equations and let's solve some linear equations down here. So the first one says solve for x. So I have negative x equals 7. So what I'm trying to do is get the x by itself. So how can I get rid of that negative sign? So how can I get rid of that negative sign?
Multiply it by -1.
Yep, absolutely. So I can just multiply or divide, it doesn't really matter, by -1, right? So the negatives will turn into a positive, so I just get x on the left, and 7 times -1 is a -7. Yep, exactly. So x equals -7. And if I want to, I can check my work, right? So I can check my work by just substituting in my answer back into the original equation. So if I do that, I get -7. So I get the negative of a negative 7, which is just a positive 7. Right? So if we wanted to check our work, we can just substitute that back in our original equation. Yep. Okay, what about B? How can I solve for x here in B? Anyone have any ideas?
It'll be the same thing. You're gonna get the 5/7 over the other side.
Yep. Yeah, so I can either divide by a negative 5/7, or I can multiply by its reciprocal, which is 7 over 5, right? Or a negative, rather. So this will get 35 over 35, which will just simplify to 1, right? So multiply by a negative 7 over 5 on both sides. So we just get x on the left. And on the right, we get, what, a negative 63 over 5?
Do you want us to simplify that even further or leave it like that?
I would leave it like that.
Okay.
I believe that the homework asks you to leave it as an improper fraction like that as well, instead of a mixed number. So, okay. Okay, what about C? How can I solve for x?
You're gonna add a positive 8.
So
I'm sorry. You're gonna subtract 8 from 15. I don't know.
yeah, so what I'm trying to do is solve for x, right? So I want to get x by itself. So on the right-hand side of the equation, the negative 8, I don't see any x's on the right-hand side, right?
Right. So you're gonna subtract 15 on each side.
Yep, absolutely. So I'm just subtracting 15 on both sides to get the x by itself. So I just get x, and that equals, what, a negative 23. Yep. And again, if I wanted to solve that, I can just plug in that negative 23 where x is, and you'll see it turns out to a negative 8. Yep. Okay. So D, it looks like we might have to simplify this a little bit, right? So how can I simplify D a little bit before I actually solve for x?
So it would be x minus positive 6 because, right?
So you said it a little weird, but yeah. So if you have minus a negative 6, you're just going to add 6, right? So it's just x plus 6. And that equals 20. So if you're subtracting a negative, it just turns into a positive, right? And then you can just subtract 6 on both sides. And you get x equals 14. Yep. Okay. All right, any questions on this first page? Okay. Okay, so this one says, complete the table that follows for the equation. So it says we have 4x plus 1 equals 9. So it says the second list should have the inverse operations in reverse order of the first. So if I want to start solving for this, I have two options, right? I can either subtract 1 on both sides, or I can divide by 4 on both sides, right? Those are my two operations that are being done to x. So the first thing that I want to do is I'm going to subtract 1. And the reason I'm subtracting 1 first is because we're kind of doing PEMDAS backwards. So if you kind of remember, we had this triangle where we did the everything in parentheses, did the exponents, multiplication and division, and then addition and subtraction. So we kind of went down the pyramid. And that's when we were simplifying equations. When we're solving equations, now we go backwards. So you do all your addition and subtraction first, then you go back up to multiplication, division, exponents, and then finally parentheses. Okay? So when you're solving, we're going backwards now. So the first thing I'm going to do for my operations to solve for x, I'm going to subtract 1. And then after I subtract the 1 on both sides, what's my equation now?
4x equals 8.
Yep, so I subtract 1 on both sides. We get 4x equals 8. And now what can I do?
Divide each side by 4.
Yep, divide each side by 4. And we get x equals 2, right? So what I did for my operations to solve for x, I subtracted by 1, and then I divided by 4. I guess that should be on the other side, sorry. So these should be reversed. So if I wanted to start with, sorry about that. So if I wanted to start with x equals 2, and I wanted to go backwards to get to this, I need to do the inverse operations of what I did over here. So the first thing I would do to get from x equals 2 to 4x equals 8 is I would multiply by 4 on both sides. So I'm just working my way backwards, right? So I have to multiply by 4 on both sides to get to here. And then how do I get from 4x equals 8 to 4x plus 1 equals 9? Well, I just do the inverse of my first operation here. So instead of subtracting 1 on both sides, we're going to add 1 on both sides. So if we're ever going backwards, if we're, let's say if we're building up our equation, we would just do the inverse operations, and we would do that in reverse order. So when we subtract 1 here, then that's our first step. The inverse is adding 1, and that will always be our last step if we're going backwards. Okay. So that was just kind of an example to ease you into two-step equations, right? So we have 2 steps to solve for this equation. Okay. So what if I have this one over here? So I have 7 plus 3x equals 4x. So how can I solve for this one? So what's a step that I could get to get all the x's by themselves on one side?
3x on each side.
Yeah, so I can just subtract 3x on both sides, right? Because then we'll have no x's on the left side, right? Because these will cancel. And how many x's do we have on the right side?
1.
Yeah, so 4x minus 3x is just x. And we just get 7 on the left side. Okay? Yep. So whenever we have this equation where we have 7 equals x, we can just flip the sides and you'll get the exact same thing. So just by convention, a lot of people, well, actually all mathematicians do this, is we always have the variables on the left and the constants or the answers on the right. But either way, these are equivalent statements. So 7 equals x is the same thing as x equals 7. So that's just a preference, but either one is a correct answer. Okay. Okay, let's look at the next one. So the next one says I have 1/2 x plus 3/2 equals 5/8 x. So what's the first step that we can do to start solving this equation? So what's the first step that we could do to solve this equation? Well, we can do something similar to what we did on the first one, right? So we could just subtract 1/2 x on both sides, right? But maybe I want to work with whole numbers, right? So a lot of the times with fractions, it gets kind of messy. So what I can do, since this is an equation, I can multiply both sides by a certain number, as long as they're the same number, and I'll still have the same equation. So what I'm going to do here is I see that I have 8 over here, which is our biggest fraction. So what I'm going to do is I'm going to multiply both sides by 8. So I'm going to multiply this side by 8 and multiply this side by 8. So that's just like doing 8 times the recipe of something, right? So you'll still have the same amount of, or the same proportion or the same ratio of ingredients on both sides. So you're allowed to multiply by 8 on both sides because it's still going to be the same equation. And the reason I'm doing that is because this divided by 8 and this multiplied by 8 will cancel. So on the right side, I get 5x rather, right? So those will cancel. And what's 1/2 multiplied by 8?
4.
4, right? So I get 4x, and then this is, I guess this is kind of misleading how I wrote it. So this 8, you have to multiply the whole side by 8. So it's just like having 8 times each part in a recipe. So you have to multiply everything on the left side by 8 and everything on the right side by 8.
That would be 12.
Yeah, so we have 8 times 3, which is 24, divided by 2 is 12. Yep. So we have 4x plus 12 equals 5x, right? And now what can we do?
Subtract the 4x from the 5x.
Yep, subtract 4x on both sides. And we get 12 on the left and x on the right. Yep, so 12 equals x, or x equals 12. Okay. And what you'll see is some of you might have been like, well, maybe I just want to solve the fraction that I have here. So this, the original equation. So you don't have to multiply by 8 on both sides, and you'll still get the same answer. So that's one of the nice things about equations, is instead of doing it in the order like I told you over here, as long as you do it correctly, you can do it in any order you want, right? Because we multiplied by 8 here first. So let's solve this again, but we're not going to multiply by 8. So I just want to show you that you're going to get the exact same answer, okay? So I'm going to rewrite the equation. So 1/2 x plus 3 over 2 equals 5 over 8 x. And I'm going to do a similar thing where I subtract the x's on both sides. So I'm going to subtract 1/2 x on this side. And I'm going to subtract 1/2 x on the other side. So my x's will cancel on this side. And does anyone know what 5/8 x minus 1/2 x is? So it's not immediately apparent, right? But I know that 1/2 x is the same thing as 4 over 8x, right? So 1/2 is the same thing as 4 over 8. So I'm going to subtract 4/8 x from 5/8 x, and we get 1/8 x. Right? And what can I do now to solve for x?
By 1/8 on each side.
Yeah, divide by 1/8 or just multiply by 8 on both sides. Yep, exactly correct. So we get 12 equals x again. So we get the exact same answer if we did it this way as if we did it the other way, right? So as long as you show your work as far as the steps that you do, and as long as you do them correctly, you're going to get the exact same answer. So we kind of get this idea that we're trying to balance both sides of the equation, right? So we're balancing it by doing it in a special way, where we're either maybe multiplying by 8 on both sides, or we're subtracting x's on both sides. So as long as you keep everything balanced, how you get to the answer doesn't necessarily matter, right? So you can do it in any way you choose as long as you do it correctly. Okay, so what about this last one? So how could I start solving for x in this last one?
Gotta solve for the stuff that's in the parentheses first. So you've got to do 2x plus 2 plus 6.
Yep. Yeah, so what you're saying is we're going to distribute this first, which is absolutely fine. So let's do that. So let's distribute this 2. So everything else I'm going to rewrite. So I still have 4x on the left. That's equal to, and like you said, you distribute this 2. So we have 2x plus 2. And then we still have plus 6. So I'm just rewriting the plus 6. So now what can we do?
Combine all the like terms. So you've got 4x equals 2x plus 8.
Yep, 4x equals 2x plus 8. Yep, that's absolutely correct. And then now we can solve it similarly to what we did on this first part, right up here. So what I'm going to do is subtract 2x on both sides. So I get 2x on the left, and I get 8 on the right. Yep. And then we can just divide both sides by 2, right?
Yep.
So divide both sides by 2. We get x equals 4. Okay, awesome. Yeah, that was great. Any questions on this page? All right, so we have some special types of equations. So this is a little bit of vocabulary. So when a linear equation results in a statement that's always true, this is known as an identity. So the solution is all real numbers. And when it results in a statement that's always false, we get an equation known as a contradiction, where there's no solution. So the example that we have, the first example they have, is we say that x minus 1 is equal to x. So to solve for this, to get all the x's on one side, we can subtract x on both sides, right? So if we subtract x on both sides, we get -1 equals 0, right? Which is definitely a false statement, right? -1 is not equal to 0. So this results in a contradiction because we get the left side is not equal to the right side, right? So that's a contradiction. So there's no value that we could put in for x to make the left and the right side equal, which makes sense, right? If we put in 10 for x, we get 10 minus 1 on the left, we get 9. So we have 9 equals 10, right? So we always subtract 1 on the left, so we know that it's never going to be equal to the right side. And then we have another example that they have down here, where we have an identity. So they had these two sides, right? They kind of distributed, solved, and went all the way down. And they got a final solution of 2 equals 2. And 2 does equal 2, right? So basically what that means is whatever value that we substitute in for x, we're always going to get a true statement. Okay, so let's see some of the examples that we could have down here. So we have 3x minus x equals 2 multiplied by the quantity of x plus 1 plus 4. So what can I do to start solving for this equation for x?
Well, first of all, we can subtract do the 3x minus x equals 2x, and then distribute everything after the equal sign.
Yep, absolutely. So we can do 2 steps at the same time, right? So we're going to combine these like terms on the left, and we're going to distribute the 2 on the right. Yep. So 3x minus x is 2x. And on the right, we get 2x plus 2, and then plus 4, right? So we distributed, and we just combined like terms on the left. So now what can we do?
Gotta do your combining. So 2x equals 2x plus 6.
Yep. So we just combined our constants on the right side. And what's the next thing that we can do?
You gotta subtract the 2x.
Yep. Subtract 2x on both sides. Right. So these two will cancel. Right. But then also these two will cancel.
That means there's no solution.
Yep. So we get 0 equals 6. And that means that there's no solution. So you can either write no solution, or there's a special symbol that we use. It's basically just a 0, and then we just put a slash through it. That just means there's no solution. Okay. What about the next one? So the next one we have, we can distribute, right? Just like we did up here. So we get 2x plus 2 on the right, and we get 2x plus 2 on the right? So 2x plus 2 on the left, 2x plus 2 on the right. So before we go any farther, what do we notice about this?
They're the exact same.
They're the exact same thing, right? So is this an identity or a contradiction?
Identity.
Yep, it's an identity, right? So when your left side looks exactly like your right side, we get an identity. And an identity means that we have a solution of all real numbers, right? So basically what that means is that we can plug in any number that we want, any number that you can think of for x, and you'll get that the left side is equal to the right side. Yep. Okay. Any questions on this one? Or either one of these? Okay. Okay. So for the last page here, so it says for each equation, State if it's sometimes, never, or always true, and then explain your response. So before we go into this, what do we call an equation, or what do we call an equation that is never true? So I'm going to start with the never. So what special term do we have for something that's never true for an equation?
Contradiction.
Yep, that's a contradiction. What about something that's always true?
Identity.
Yep. So that's an identity. And what about something that's sometimes true? Well, that's just when we have one solution, right? Like what we did at the very start. So I'm just going to say that we have one solution here. So we just have one solution. So it's only true when we get x equals some value, okay? Okay, so let's solve for these. And then when we solve for them, we can find out if they're sometimes, never, or always true, right? So how can I start solving for this first one? So we have a few options that we can do. So how can I start solving for this first equation? So we
Well,
have
let's start off by subtracting 9 from each side.
subtracting 9x from each side. Sure,
Mhm.
we can do that, absolutely. So we have a decision. So our decision is, do we want all the x's on the left side or all the x's on the right side? So here you choose to have all the x's on the left side, right? Because these two will cancel. So since we made that decision to have all the x's on the left, now we need to make the decision to have all the constants on the right, right? So I'm going to rewrite this. So we have 5 minus 16x equals 24. So now, since we made that decision, now we're forced to subtract 5 on both sides. Right? Because we want all the constants on the right and all the x's on the left. So we get negative 16x equals, what, 19? And then how can we get the x by itself now?
Divide it on each side.
Yep, so we get x equals a negative 19 over 16, right? Because we just divide by 16 on both sides, or negative 16 rather. Okay. Yep. So is this sometimes, always, or never true?
Would be sometimes, because it's one solution.
Right, so we have exactly one solution for x. So this equation here is only true when we get x equals negative 19 over 16. So if we plug in x equals 3 to this, we're not going to get a true statement. It's only true when we have this exact answer. So this is sometimes true. And that's because we have one solution. Yep. Okay. What about the next one? What could my first step be for the next one?
You have to distribute.
Sure. So let's try something different though. So
Okay.
what I'm going to do here is I see that I have -8, -4, and 20 over here, right? And I know that 2 goes in evenly to each one of those, right? So we have 4 times 2 is 8, 2 times 2 is 4, and 2 times 10 is 20, right? So instead of distributing this 2, what I'm going to do is I'm going to divide both sides. So I'm going to divide the whole thing by -2.
Oh.
Because I know that I'm distributing this -2 to each one of these anyway. So if I divide by -2 on the left side, these two will just cancel, right? Because I'm distributing it to every one of these as well.
Okay.
So the -2's will cancel. On the left side, I just end up with whatever's inside the parentheses. So I get 5x minus 15 plus 6. And on the right side, I have to divide everything by -2. So I have -8 divided by -2. I get a positive 4. I have a -4 divided by a -2, which is a positive 2. And then 20x divided by -2 is -10x. Yep. Okay. So Now I can start solving for it a little bit more, right? And not to say that your way of solving it's wrong. If you distribute, you're still going to get the same answer.
It just took a lot more steps.
Yep, absolutely.
Right.
Okay, so now I can combine my constants, right? So let's combine these two on the left side and combine the two on the right side. So I get 5x minus 9 on the left. And we get 4 plus 2 on the right, which is 6 minus 10x. Okay, so I have my left pretty much combined, my right pretty much combined. Now we have to make a decision. Do we want all our x's on the left or we don't want all our x's on the right? So I'm going to choose to have all our x's go to the left side. And I'm going to do that by adding 10x on both sides. So I'm going to add 10x on both sides. Right? And then since I made that decision, now I need all my constants to be on the right side. So I'm going to do both of these in one step. So I'm just going to add 9 on both sides. All right, so I'm canceling all my x's on the left side. I'm canceling all my constants on the right side. So I end up with all x's on the left, which is 15x. And I get 6 plus 9 on the right, which is 15. And then my final step is just dividing by 15 on both sides. So divide by 15 on both sides, we get x equals 1. So we've solved this equation. We've got exactly one solution. And since we have exactly one solution, that means that this is only sometimes true. So this is sometimes true, and there's exactly one solution. Okay. Okay, so what about this last equation here? So before I do anything to it, can anybody tell me anything about the left and the right side? Maybe how they look, anything like that. So what do I notice? Or another way I could put it is before we even solve this equation, because maybe we don't actually need to, can you tell me right away if it's an identity, a contradiction, or if it's sometimes true?
It's going to be an identity.
Why is it going to be an identity?
Because if you add the 2 to the 5, -5, you're going to get 3.
Okay, so if yeah, sure.
Of -3. So, I mean, everything is just, there's 3s all the way across the board.
Sure, so we get 3x. So if I start solving this, sure. So I get 3x equals 3x minus 3. Right. So we're down to that step, right? So an identity is always true, right? So can you think of any number that we could plug in?
I'm sorry, it would be a contradiction.
Contradiction, right? Yeah, so we notice that we have 3x minus 2 over here and 3x minus 5 over here. So there's no number that we could plug in here to make this true, right? Because we always have some number multiplied by 3 on both sides. But on one side, we're subtracting 2, and the other side, we're subtracting 5, right? So this will always be a contradiction because there's no number that we can plug in to make this true. So I guess I should reverse the order. It's never true because it's a contradiction, okay? So if I wanted to finish this out, I could just subtract 3x on both sides.
Right.
Yep. So we get 0 on the left and we get -3 on the right, right? So this is a contradiction. We get 0 equals -3, which is never true.